All right, let's dive right into this explainer and crack open the hood of AI agents. For years now, we've basically been treating AI like a really, really smart but totally passive encyclopedia. We ask it a question, it gives us an answer, and then we have to go out and do the actual work ourselves. But that is changing incredibly fast. Today, we're looking at how AI is shifting from being just a passive conversationalist to an active orchestrator. We're going to use the massively popular open source project OpenClaw as our technical guide to see exactly how this transition from just knowing things to actually doing things works on a structural level.
Here's a quick look at our roadmap for today's explainer. We'll start with the shift from knowing to doing, look inside the Agentic Loop, map out the OpenClaw architecture, explore automation tools and skills, and finally cover some critical security and governance mechanics.
Kicking things off with Section 1, from knowing to doing. So, let's start with a fundamental problem we're all facing. We are wasting a ton of time acting as the manual middleman for our AI. Think about your typical interaction with a chatbot right now. You ask it to help you draft an email, or, say, schedule a meeting. It gives you a great template or tells you exactly how to find an open time slot. But what happens next? Well, you switch tabs. You copy and paste the text into Gmail. You look at your calendar availability, and you click the buttons. That is what we call the knowing phase. The chatbot knows what to do, but you are the one doing all the heavy lifting. AI agents, on the other hand, represent the doing phase. This is the new paradigm where an agent connects the large language model directly to your tools, running entirely autonomously. You tell it to schedule a meeting, and it actually goes into your calendar, checks the dates, and books the whole thing for you.
Which brings us to Section 2, inside the Agentic Loop.
Now, you might be wondering, how does an agent actually process a complex task without any human intervention? Well, unlike a simple prompt and response interaction, an agentic loop combines an LLM with the ability to use tools and take autonomous actions. And this is where the real magic happens. When a task comes in, the agent doesn't just instantly spit out a text response. Instead, it continuously assembles this massive context window. It pulls together the conversation history, its own long-term memory, system instructions, and crucially, a list of available tools it can use to solve your specific problem.
We call this continuous methodical cycle the REACT pattern. That stands for reasoning and acting. Here's how it flows. First, the agent reasons. It looks at the assembled context and asks itself, okay, do I need to use a tool to pull in more data to fulfill this request? If the answer is yes, it moves to step 2, act. It might execute a terminal command to read a local file on your hard drive, run a web search, or call an external API. Finally, step 3 is observe. When that tool executes, the agent receives the result and feeds that brand new information directly back into its original context window.
And here's the absolute crucial part of all this. It is an iterative loop. The agent doesn't just stop after one action. It takes that new context and it reasons again. This cycle of reasoning, acting, and observing only breaks when the agent determines, all right, no further tools are needed, the task is completely resolved. Only then does it wrap up all that work and deliver the final response back to you. This REACT pattern is literally the core engine driving virtually every agent framework out there right now.
Moving on to Section 3, OpenClaw Gateway and Adapters.
Let's actually look at OpenClaw to see this loop in action. Getting this Node.js service running locally is actually super straightforward. You literally just clone the repository, run npm install, configure your environment variables with your API keys, and spin up the server. It follows a hub-and-spoke model, and at the absolute center of that model is the gateway. Think of the gateway as the grand central station of the entire operation. It's an always-on WebSocket server acting as the control plane. It handles message routing, session management, the creation of multiple agents, and coordinates all the tool usage. Every piece of data flowing between your local databases, your prompt templates, and the LLM passes right through this central gateway.
But how do you actually talk to this gateway, right? You aren't just limited to standard web interfaces or command lines. You can message your agent through Slack, Microsoft Teams, Discord, or even iMessage. And this is where adapters come in. An adapter acts as a bridge. It intercepts those raw, messy JSON payloads coming from all these diverse platforms and standardizes them into one unified internal format so the gateway can actually process it. It's just a remarkably clean architecture that lets you reach your personal assistant wherever you already happen to be working.
All right, Section 4, automating with tools and skills.
Now that we have a solid connection established, let's explore the execution layer. This is where the actual heavy lifting gets done, and this layer is split into two distinct categories, tools and skills. The agent relies on built-in tools for its basic interaction with your environment. We're talking about native capabilities here, like web browser automation or direct access to your machine's terminal. But skills are what make OpenClaw so wonderfully extensible. They are essentially individual folders containing Markdown files, and these Markdown files act as custom instructions designed to teach your agent entirely new workflows and how to perform highly specific tasks.
There's a massive technical hurdle here, though. If the agent fed the instructions for every single skill it knows into the LLM at the very beginning of a task, the context window would instantly fill up and the whole thing would crash. OpenClaw makes a brilliant architectural choice to prevent this. It actually doesn't automatically give all this information to the model. Instead, it only injects the available skills and some brief metadata up front. It lets the LLM reason about the task first and then pick and pull the full instructions for a specific skill completely on demand.
So what kind of workflows can these skills actually enable? The possibilities are honestly massive. You can teach your model to manage your Trello boards, dive into your Google Calendar to edit events, or connect directly to your company's CRM or GitHub. For engineers, the agent can even use Docker to build, run, and test container images entirely on its own. Whether triggered on demand via a quick Slack message or scheduled as an automated cron job running in the background, these skills allow the agent to completely take over those daily, repetitive manual tasks.
And finally, Section 5, Security Risks and Governance.
Okay, before we get too excited and hand over the keys to our digital lives, we really need to address the terrifying reality of local automation. Because systems like OpenClaw run locally as Node.js services with direct, unfettered access to your file system and terminal, a single misconfigured environment can literally lead to a powerful backdoor right on your own machine. As we speak, there are thousands of internet-exposed OpenClaw instances out there, completely vulnerable to attack. And this usually happens either due to poor setup configuration or simply because users downloaded skills from the internet that secretly contained malicious code.
The absolute biggest threat vector in this environment is prompt injection. This is a vulnerability where the agent processes an untrusted input that contains hidden malicious instructions. Because the LLM acts as the reasoning engine, it might read those hidden instructions and just execute them, fully thinking they're legitimate commands from you. Imagine your agent reads a seemingly normal email or a web page that secretly commands it to delete your hard drive. Because the agent has real terminal access, it could actually do it. That is the very real danger of prompt injection in the agentic era.
So how on earth do enterprise teams manage this safely? Well, you absolutely must follow a strict defensive governance playbook. First, always run your agents in isolated containerized environments or secure virtual machines, strictly limiting their network permissions. Second, enforce rigorous code reviews and CI/CD pipelines for any custom skill markdowns to catch exploits before letting the agent loose. And third, ensure you are encrypting all credentials before sending them anywhere near the LLM.
Your AI can now orchestrate your computer locally. It can reason, it can act, and it can observe. As we leave behind the era of passive chatbots and enter this wild new age of active orchestration frameworks like OpenClaw and LangGraph, you really have to ask yourself, are your environments truly secure enough to let it? It's the ultimate balance, right? Incredible time-saving convenience on one hand versus a monumental security risk on the other. It's definitely something to really think about as you start building your own agentic loops. Thanks for joining me on this explainer, and keep questioning how your tech works.